Hi everyone, my name is Jean-Christophe. In this Python tutorial, I'm going to show you how to use Scikit-learn's K-neighbors classifiers and how to perform K-nearest neighbor in Scikit-learn. So what KNN is, it's an algorithm used in supervised learning for both classification and regression. And essentially is you try to classify data into or multiple categories based on the closest neighbors. So if you have some prediction here, you can say, okay, if I'm looking at three variable in that circle, I'm going to have this classification. And so if k is equal to 3, then I will classify it as green or class B. And if K is 6, since it's bigger, I have 4 items in that class 6 and 2 in green, then I'm classifying it as class A. So in a nutshell, that's how KNN works. If you want to learn more, make sure that you look at my tutorial online. Otherwise, let's get started. So I have loaded this data for you, and essentially what I'm doing is I'm loading the breast cancer data set, and I have all these features that try to predict something which is malignant or benign. So I have these features, and what I'm trying to predict is whether cancer is malignant or benign in breast cancer data set. So I'm gonna since Scikit-learn requires us to use numerical data arrays, I'm going to assign the data set to X and Y. And then I'm going to get started with data preparation and splitting. So whenever we run machine learning model, what we want to do is we want to make sure that we have a test set and a control set so that we can look at accuracy. And this is essentially what this does. You can look at my tutorial on train test split if you want to understand what this does, but essentially it creates, it splits my data in a 30% test group. So let's run this and let's dive into the meat of the subject, which is the actual k-nearest neighbor. And in order to run a KNN algorithm with Scikit-learn, we need to, from Sklearn, the neighbors. So it's within neighbors module, you import k nearest neighbor, k-neighbors classifier. And in order to train the model, we generally use the naming convention KNN, and we use KNeighbors classifier. And the first parameter that we want to use, the parameter whatever we want to set is the number of neighbors, and that's the K value I was talking to you about. So in this case, we'll randomly select 8, and I'm going to show you how to select that value later. And then we do knn.fit at xtrain and Y train, and then we will predict using knn.predict x test. So here the fit method is the actual training of the data set, so that that's why we put the training data in there. And the predict method is where we put in the test. So we're trying to predict Y test. So here that's why we have splitted X test, Y train, and we're gonna try to predict Y test. And in order to compare the score, we're gonna compare Y test to the actual Y prediction data. And that's how we compute accuracy. So we do knn.score, and we add X test and Y test. So we will look at that information, and currently our prediction accuracy is 92.9%. So 92.9% of the time we are right. And that happens because this data set is a clean data set, so we don't have too much pre-processing to do. But let's dive into that information. So what we want to know is how many neighbors should we actually put in the data. So what I'm going to do is I'm going to make a plot that will tell us this information. So I have the same split and training, the same data here, and I'm gonna create variable where to store the information. So we start with the same starting point of as what we have done, but what we're gonna do is we're gonna try to loop through multiple values. So what we can do is we can say neighbors equal NP a range 1 to 26. So essentially, what this NPA range will do is that it will create a range of value from 1, 2, 3, 4 up to 26, and we are going to loop for each of these values. So in this case, if I print neighbor, you'll see that what I'm doing is I'm actually looping through all the value 1 to 25. And what we want to do is we want to train a model using that value every time. So we use KNeighborsClassifier and neighbors equal, and then we put the number of the neighbor. So here we will train it at 1, train it 2, and then we'll expand up to 25 in order to try to find the best, um, their best value for n neighbors. So we will train the model at fit and X train, Y train. And then what we will do is with the training value, we will try to assign the test accuracy and the train accuracy, the training accuracy and the test accuracy. And here for each neighbor, essentially, we will assign the KNN score. So KNN.score. So that's our accuracy score, X train, Y train. And then here I'm gonna do the same, but instead of X train, Y train, it will be X test, Y test. So I'm gonna plot, so I'm gonna have this, this value here. And what I wanna do is actually plot this information. So I'm gonna plot my title here with matplotlib, hence why I've imported matplotlib. Uh, and then what I do is I will need to plot the neighbors. So I'm taking all the neighbors for the X value, and I'm gonna put the train accuracies values, and the label here will be train accuracy. And I can do the same with the test accuracies and say test accuracy. And then I will plot a legend, plot X label, and plot show. Let me show you what this is gonna do. It just plots this information in order to tell us that somewhere around here, before it plateaus, we have the best possible n neighbors. And over here to the right, that's where we start overfitting the data. So this is a plot that shows you the accuracy by number of neighbor. We can also actually do grid search CV in order to predict the right, get the actual right end neighbor. So what we're going to do is we are going to run parent grid, and I'm gonna not going to go too deep into the grid search CV because this is a KNN tutorial, but let me show you here. I'm gonna use neighbor from NPA range from 1 to 50, and I'm gonna use grid search CV, KNN CV equal grid search CV, and I'm gonna use KNN param grid and CV equal 5. Cross-validation equal 5. Let's not dive too deep into what this means, but we can use now KNN CV to fit on the X train and Y train. And what this will do is that it will go through all the n neighbor and fit the model. And what it will show is we can show the print KNN CV best params, and we can print we can print the best score as well. So essentially, by doing this, we will be able to know what are the best parameter and what will be the accuracy score for this best series of parameter. And in this case, it tells us that uh, we should use 6 neighbor with an accuracy of almost 95%. And here, when we show you the plot earlier, we were around 6 parameters. So we were right just by looking at the plot, but grid search CV is a much better way. If we look at our previous, we had 90%, 92% accuracy, and now we are showing 95% accuracy, which is fantastic. Now we can evaluate the model, and one of the way that we can do this is by using confusion matrix. If you don't know what a confusion matrix is, I have a tutorial on the topic here on my website, but essentially it shows you the true positive, true negative, false negatives, and false positives. So essentially is how often you are right and how often you are wrong, or I won't dive too much into this, but you can look at that accuracy by using CM equal confusion matrix. And this is useful. It's again not a tutorial on KNN, but not on confusion matrix, but it's helpful to go when you look at your KNN accuracy. You can look at your labels, and then you do KNN classes. So we are going to show this. I'm putting some color and I'm putting a display, and I'm going to use confusion matrix display, because if I just run confusion matrix, what I have is an array like this, which you can interpret. If you want to make it more visual, then you commit to with confusion matrix display, and you can put display labels equal KNN classes. So essentially, you are just making a beautiful plot with this. And then you can plot the title and plot the confusion matrix plot, and then you can see your true labels. And if you want to interpret this, what it means is that you have 102 instances when you correctly predicted the benign, and 57 instances when you correctly predicted malignant. Let's not dive too much, but you can interpret this, and the way you are going to go further is by looking at the classification report, and that's where you can have your actual metrics. So you go from Sklearn metrics, import classification report, and then you can print classification report with your white test white bread. So you're comparing your prediction against your initial test information, and you get that report. Again, I have a tutorial here that can tell you what the classification report is, but essentially what you want to learn is your accuracy here is 93%. And that says how often you were right when predicting. And the other information that you can look is here the class one. So essentially, if we come back to our problem here, we try to define how often we can predict cancer as malignant. And so what we can look here, we can look at the precision and recall. And what the precision says is that when you predicted cancer, how often was it really cancer? And the answer is 94% of the time when we predicted someone had cancer, it was really cancer. And the recall here is what percentage of the real cancers, of all the cancers that existed, so the true positive and the false negative, uh, of all the real cancers, what is the percentage that we could predict is 95%. So these number in a cases of cancer, it should be really, really high, and that's what we have in this case. Now let's dive into feature scaling. Uh, Here we have a specific case where the data set is quite clean, but with KNN, KNN is really sensitive to the scale of the data. So if you have something that are on a very large scale and some other features that are on a tiny scale, this really can skew the calculations because the distance won't map to the same thing. Here, if you want to scale the data. So one way you can do this is you might want to convert uh, the mean to be 0 and the standard deviation to be 1. Um, and so essentially you have one standard deviation everywhere. And one way you can do this is you can use standard scalar. And to do this, you just instantiate a scalar. And then you just run xtrain scaled equals scalar fit transform, and you can run xtest scale and you run scalar, and then you just transform because you don't want to fit on the test data. Forgot to say xtain X test. So you don't want to train on the test data. That's why you're just transforming. And if we plot the results here, we have the original mean and standard deviation. And once we have transformed it, we have this mean and standard deviation. In order to do this within the pipeline with KNeighborsClassifiers, we start with the same initial step that we've done so far. We run the train test plate, and then we create a steps variable. And the steps variable should be a list, and each step should be what you're trying to do. Here we have a scalar, and we can run standard scalar. The list should be tuples, and we have KNN, and what we have here is KNeighborsClassifiers, and neighbors should be 6 because we learned that information earlier. And then we train the data in a separate way by running a pipeline. So we instantiate pipeline equals pipeline. And within the pipeline, we give the steps tuple. Then we can train the model using KNN scaled equals pipeline. Instead of using KNN.fit, this time we use pipeline.fit, and we put in the X train, Y train, and then we predict using the KNN scale predict on X test again. And then we can print the pipeline score, and that's how you train a model using a pipeline. So thank you very much. That was all for this K-Neighbors classifier with Scikit-learn tutorial. Make sure to subscribe to my channel or visit my website or follow me on the social media. Thank you very much. See you next time.